Okay, day 25. Date is this Sunday, 17th November, and we are understanding exploratory data analysis. What is the exploratory data analysis? Exploratory data analysis is to encourage the statisticians to explore the data and possibly formulate the hypothesis that might cause the new data collection and the experiments. EDA focuses more narrowly on the checking the assumptions required for model fitting and the hypothesis testing. It also checks while handling the missing values and making the transformations. Missing values and and it also checks while handling the missing values and making transformations of the variables as needed. So when you talk about the EDA, exploratory data analysis, in the exploratory data analysis, we need to understand, we need to first understand what is EDA? Why do we need EDA? So exploratory data analysis builds the robust understanding of the data and issues associated with either the info or the process. It is the scientific approach to get the story of the data. It is the scientific approach to get what? The story of the data. What is EDA then? When you talk about the EDA, exploratory data analysis, meaning of the EDA is understanding your data whole and soul. You understand what I'm trying to say? Understanding of the data whole and soul. That is nothing but what the EDA is. Exploratory data analysis. Exploratory data analysis. Okay, so this is one thing. Now, when you talk about the EDA, what exactly you wanted to do? Just a minute. So yesterday we talked about the Seaborn. Yesterday we talked about the Seaborn, one of the library. Just a minute. So remember that we have learned the tools, right? We have learned the tools for performing the EDA. So first tool we have discussed is Python. Python is okay, you can consider it Python. Then we discussed NumPy, Pandas, and Seaborn. Now, mostly you will do a lot of things with the Pandas and the Seaborn. So when you talk about the EDA, remember that it is the scientific approach. When you talk about the EDA, it is the scientific approach of understanding of the data. Of understanding of what? Data. Now there are few types of EDA are available. There are the types of EDA are available. These are the tools we have used. And these are the few types of the EDA. Univariate non-graphical. Univariate non-graphical. Name itself is suggesting on a single variable non-graphical. There would be no images. Multivariate non-graphical. Multivariate non-graphical. What happened? Then univariate graphical. Univariate graphical. Multivariate graphical. Multivariate graphical. So univariate non-graphical, this is the simplest form of the EDA. So whatever we have done with the pandas, now what is univariate, multivariate? We'll talk about that. Only pandas. You have a CSV. You are not allowed to use any of the graphs, any of the plots. That is the univariate, non-graphical. This is the simplest form of the data analysis. During this, we use just one variable to research the info. The standard goal of the univariate non-graphical EDA is to know the underlying sample distribution of the data and make the observations about the population. The outlier detection is additionally part of the analysis. The characteristics of the population distribution include the central tendency, spread, skewness, and the kurtosis. What do you mean by univariate, non-graphical? We will just talk about what you can say, a single variable, a single point without graphical understanding. So what you can do? Okay, do we have the notebook? Just a minute. A univariate. When you talk about the univariate, we understand the few things like a single variable like central tendency, spread, skewness, and the kurtosis. Now, what is that kurtosis means? We will see a statistical term. So when you talk about the central tendency, measures like mean, median, and the mode, spread, the variance and the standard deviation describe the how much data deviates from the central value. A skewness, asymmetry in the distribution. Kurtosis means the peakedness or the sharpness of the distribution compared to the normal distribution. Okay. Now how to do that thing? Let's do some sample code. import pandas as PD, import pandas as PD, import numpy, okay, just connect the VM, numpy as NP, and from scipy dot stats, ready-made formulas we are importing using third-party library, scipy, kurtosis and skew. Kurtosis and what? Skew. Now remember that these are the statistical terms. Kurtosis and the skew, these are coming from the stats. We'll talk about that as well in short. So let's create the panda. So I will not use what you can say. I will not use any CSV because it would be having a huge amount of data. And I need few things. So let's have a scores, a variable. We are creating the directory scores. Let's try to understand these terms by means of the actual code. And here, so this is some data 55, 60. If you see 55, 60, 65, 65, 65, 70, 75, 80, 85, 90, 95. So these things are understandable, and here 200 over here is an outlier. Why? So the data is related. Data is what? Related. But the 200, there is no association between this data and this 130 and 200. If you see, there is association 55, 60, 65, 60, 65, 65. So they are associated over here somehow. But this thing is not, is an odd man for these things. So identifying these things in a data is a part of the univariate non-graphical. What do you mean by univariate non-graphical? Exploratory analysis focuses on understanding of the characteristics of the single variable. Single variable. So we don't have, so here this is just an few numbers over here we have. So from these numbers, what we can conclude, what's the mean, what's the median, what's the standard deviation, right? There is nothing we can do with this data other than this, because there are only such things are available in a data. Now let's try to calculate few things. So let's convert this thing to the data frame first. Df is equals to pd dot data frame. We have created the data frame. Now you tell me a central tendency. How do we calculate the central tendency? Central tendency. Remember that exploratory data analysis is for the statisticians to explore the data and possibly formulate the hypothesis that might cause the new data collection and the experiments. EDA focuses more narrowly on checking the assumptions required for the model fitting and the hypothesis testing. It checks over here from this data which values are missing. Now there are different types of the EDA are available. Univariate, non-graphical. There is no graphics. We will just get to know few terms from the stats. Central tendency. We will be having hash spread, data spread, right? Skewness, and so these are the statistical terms. Skewness, and kurtosis. Skewness and the kurtosis. Now, so this thing is coming from, can you see the data is how data is distributed? Normal distribution or how? That you will get to know by means of this thing. The central tendency or the location of distribution has got to do with the typical or the middle values. What is the mid of this data? Middle values. The commonly useful measures for the central tendency are in stats called as mean and the medium, and sometimes mode. Mean, medium and the mode, during which foremost common is a mean. What is the mean of this data? Mean of this data. That's what we will do in a central tendency. What is the mid of the data? Right. For the skewed distribution, or when there is a concern about the outlier, the median may be performed. Mean, median and the mode. These three things we will do. Let's try to do it first and then again we will come back to theory. So here we can say mean underscore value. How do you calculate the mean? So yeah, this is what we will do. Mean underscore value, df dot score mean, median, and these things. Let's try to print all these things. Print. Okay, run it and see. If you see, mean is 93 point something like this, and the median 85 something like this. So mean calculates the average value. Remember that. When you say mean, calculates the average value. Median finds the middle value of the sorted data. Finds the middle value of the sorted data. And the mode determines the frequent value. Can you see 65 is the frequent over here? So it is saying that 0 and the 65. Mode determines the most frequent value, 65. Okay. Now, when you talk about the central tendency, you are talking about these things. Is that clear? Hello? Is that clear? Central tendency, mean value, median value, mode value. What is exploratory data analysis? There are 4 types of the exploratory data analysis. Everyone please respond if it is clear to you. If not, please ask me the query. Clear? So what we are trying to do, with this data, what the most things you can do? There is no relationship. For the relationship, there are no multiple columns. Only few columns are there. Now, what do you mean by spread? A standard deviation. Spread means what? The standard deviation we need to calculate, and the variance. Standard deviation, spread, range of how values are spreaded, the max value, mean value, the variance value, right, and the standard deviation. Now what do you mean by variance? Computes the variance, the standard deviation. Now standard deviation and variance. Standard deviation and variance wiki. If you go to here, if this is how your data is distributed, this thing is called as normal distribution. In the statistics, standard deviation the is a measure of the amount of variation of the values of a variable about its mean. About its what? Mean. A low standard deviation indicates that the values tend to be close to the mean. Low standard deviation. Low standard deviation indicates that the values tend to be close to the mean, right? Also called as the expected value of the set. While the high standard deviation indicates that the values are spread out over the wider range. The standard deviation is commonly used in determination of what constitutes an outlier. What is the definition of the outlier is given to you by the standard deviation. What is the outlier and what is not? Who defines it? The standard deviation, right? So how much value is closer to the mean and how much value is away from the mean is the standard deviation. In the statistics, the standard deviation is a measure of amount of variation of the values about its mean. A low standard deviation indicates that the values tend to be close to the mean. The low standard deviation indicates that the values are close to the mean, while the high standard deviation indicates that values spread are wider over the range. Now, what is the variance? So, this is the standard deviation. What is the variance? So, in the probability, it is coming from the probability. In the probability theory and the statistics, a variance is an expected value of the standard deviation from the mean of a random variable. Okay. Now there is a formula to calculate it. Variance of this is E. Then this determinant x minus mu, mu is the standard deviation and the square. Right. So let's not worry about this thing right now. Okay. In the probability theory and the statistics, the variance is expected value of the squared deviation from the mean of a random variable. So same thing they have written in the form of formula. So this line in the probability or statistic theory, variance is the expected value E, right? This is the E. So this is the your array over here. This is the standard deviation what we got, and if you make a square of it, you will get the variance. Now how do you calculate the variance? See here, df scores is our array. Okay, dot var means what? The variance. Just remove this thing and run it. So here you can say print variance and the standard deviation. So here you will get the just a minute. So standard deviation is the 36920, variance 1363. Now standard deviation means what? We talked about that. It is how much value are away from the mean. The higher the standard deviation, values are spreaded. Lower the standard deviation indicates that values tend to be close to the mean. Okay, values tend to be close to the mean. Now whenever we are performing the EDA, right, you need to know what is the variance and what is the standard deviation. So these two things are coming from the typically stats. This is the formula for calculating the variance, where of x is equals to expected value. So your number minus standard deviation square. Your number minus standard deviation square. So this will tell you how values are how values are how values are spreaded, your expected value, right, how it is spreaded over the distribution. That has been told to you by this variance. So whenever you are performing EDA, the first step is univariate. What is univariate? Coming to the conclusion that how values are spreaded. Okay, so standard deviation and the variance. Okay, so here if you see, standard deviation is 36 and the variance is 1363. 1363. So when you say the standard deviation is 35, which means that, okay, let's do one thing. Let's remove this 200. This is the outlier present. That's why it is showing you the something like this. Run it, run it, run it. And now see, it is 23. It is what? 23. So you have removed that 200 from there and your standard deviation has been reduced. Your variance has been reduced drastically. Why? There is no outlier in this thing now. The things are related. The things are somehow related. If there is an outlier, you will get the spread is bigger. The values are spreaded bigger, and that's why you will get this something like this. Is that clear? Hello? Am I audible? Now the skewness and the kurtosis. Okay. So when you talk about the skew, measures the asymmetry of the data distribution. There are two types of the skews. Positive skew, a long tail to the right. Negative, just a minute. Skew in EDA. Let's go to the images. Yeah. So here if you see this thing or this image, positive skew. What do you mean by positive skew? Tail is towards the right, long tail towards the right. Negative skew, long tail towards the left. This is a positive skew, negative skew, and the symmetric distribution. Can you see? Mean, median, and the mode are on the one line. Positive skew, this is the mean. This is the mean. So median is to the left. Remember that. Median is to the left is the positive skew. If mean is here, median is to the left, positive skew. If mean is here and median is to the right, it is the negative skew. And if mean, median, and other things are same, it is the symmetrical distribution. Data is normally distributed. Data is what? Normally distributed. Now, what is the kurtosis? See now. So, so if you have seen this kind of a diagram, this kind of a diagram, this is the kurtosis. What kurtosis says? Evaluates the peak of the data distribution compared to the normal distribution. Evaluates the peak, this thing, of the data distribution as compared to the normal. Now, positive kurtosis, sharper peak, flatter, this is the flatter, this is the positive, flatter and the positive. Positive kurtosis, sharper peak and the flatter peak. Just a minute. If we need to print this guy, let's first calculate the skew and kurtosis. The skewness value 1 point something like this, 1.69. Positive skew showing the long tail towards the right due to the outlier. Kurtosis 2.64 indicates the sharper peak compared to this thing. Now, if you want to plot this thing, okay, let's try to visualize, because we have talked about this. Let's try to visualize. So here we can say matplotlib we imported or not. We need to import the Seaborn and matplotlib, two libraries we need to import here. So let's create the figure over here. This much would be the figure. We didn't run it. Run this, this one, this one. Now run it. Okay. Now histogram we will print it. Will today or in the next session we will understand what is the histogram is. S is small. Yeah, see here. So skewness. So this histogram with the KDE skewness. If you see the value, look at the data. So here 110, 120, 130. There are no in between values. Direct 200. 200 becomes the outlier. And can you see? And that's why here you cannot see any bars in between. You cannot see any bars between. So towards the right, tail is long towards the right over here. So what kind of skew it is? It is the positive skew, long tail. So this is the tail which is going towards the right side, long tail towards the right. It is positive skew. Because of this outlier this is happening. Remember that because of this 200 this is happening. So you can say that somewhere here there would be the mean, somewhere there. Here would be the mean, and right to the mean there are few things. Okay, and that's why this is happening, the positive skew. Now kurtosis, let's try to print it. And run it. Box plot. So to understand the things, we use the box plot. Now see, it is also saying same thing. Your values are starting from here. One thing is represents mean median. We are going to talk about this thing. And 200 over here. This is the outlier. This is what? The outlier. You have outlier over here. Now, the box plot displays the data distribution and the highlights. So, pickedness via the presence of the tight and the spread whiskers in the box. Outlier marked as a point over here. This is what the outlier. And here you can see the distribution of the data is something like this. Here you can see the distribution of the data. It's something like this. Histogram. So it represents the skewness. It's the positive skew. Why? Because of this outlier. So I'm not taking the difficult database like actual CSVs. Actual CSVs also no problem. You can, this is one column, only one column we have right now. We can have the multiple columns also, but I'm taking minimal and values are also minimal to, so you can imagine over here it's a 200. Now you can imagine what is the mean, you can imagine what is the median, right? By looking at the data you can imagine the mean, median. So these are the statistical terms: mean, median, skew, kurtosis. What is the mean? Average value is the mean. Average value is the mean. What is the median? A middle value. It will try to figure it out the middle value of the sorted data. And the mode, most frequent value. Here it will try to find out the most frequent value. The spread, how data is spreaded, is calculated by the standard deviation and the variance. How data is spreaded computes the standard deviation, which measures the data dispersion. Variance, the squared standard deviation. Squared standard deviation. Skew measures the asymmetry of the data. So data is asymmetrical towards the right. Kurtosis evaluates the peak of the data distribution compared to the normal distribution. Peak of the data distribution compared to the normal data distribution. And these things are used to find the outlier. In this data, there is an outlier. To finding out the outlier is really important. Yesterday also we talked about these things. Yesterday also we talked about what? These things. So we have covered the univariate with the graphical. So this is the univariate with the graphical. Few graphs we have talked. We are going to discuss more graphs or the plots in detail. Don't worry about it. But whenever you talk about the exploratory data analysis is done on these kind of things. Okay. Now what is the multivariate? What is the multivariate? Multivariate non-graphical first we will see. And multivariate graphical is all about the plots. We are going to put the plots. Okay. Any question guys on this part?
Aniruddha, can you please show the code?
Yeah. all about the data frames.
Scroll down.
I'll be back in a minute. Any queries? Hello? Is that clear, guys? Hello? Give me some reaction. Now, these things might be new to you, right? But the statisticians use these things daily. Whenever you give them an Excel sheet, first they will calculate the mean, median, skew, kurtosis. That's it, right? If you want to read, see, there are the mathematical formulas implemented over here to calculate the standard deviations. There are a lot of theory behind this is available, but we are simply using one function here. If you see dot std, the standard deviation, df scores dot std, internally this formula have been implemented. Remember that internally these formulas are implemented by the pandas team. Hello? Are you there, guys?
Yes.
So if you want to read the theory behind the standard deviation, you can go over here. But this is a standard formula. If you want to calculate the standard deviation in Excel also, there is a standard formula. But this is the theory. Variance, it is the theory. Okay. Now, I will again come back to the box plot shortly. Now, univariate means what? Can you see the data is having only single attribute score? In this data, it is having only single attribute score. So, it is univariate, and statistics says that univariate analysis focuses on the single variable. Central tendency, mean median mode, spread, how data is spreaded, standard deviation variance, shape, skewness and the kurtosis, and the outliers. Whenever you talk about a univariate, not a fancy term, univariate, only single variable scores. Multivariate with the categorical. Multivariate. Now, what do you mean by multivariate? So, here this data would be having multiple things, category, subcategory, scores. Category, subcategory, scores. Multivariate non-graphical. What do you do in a multivariate non-graphical? Right? What do you do in a multivariate non-graphical? In a multivariate non-graphical, you calculate in a multivariate non-graphical, just a minute, cross tabulation and the statistical for the categorical and the quantitative variables. Computes the statistics. Now if you see, so these are the strings, these are the numbers, categorical data. Category is nothing but, this is the name, this can be anything, but look at the data. Your computer never understand the strings. Computer only understand the bytes, bits and bytes. So this data is not understandable by the computer. You need to convert it to the bits and bytes, right? So cross tabulation used for the categorical data to show the frequency distribution of the combination of the categories and displays the relationship between the two variables as a two-dimensional matrix of count. What is the relationship between category and the subcategory? What is the relationship between the subcategory and the scores? Category and the scores. You getting my point? So this thing has been done by this thing have been done by the multivariate non-graphical. Cross tabulation. Cross tabulation means what? We will create the table between these three things. The relationship table between how the values are associated with each other. We need to calculate that. So in our data, what our data is containing? A category key, a primary categorical variable. Categorical variable ABCD. We just have the ABCDs over here. Subcategory, a secondary category with the X and Y. Only X and Y's are there. And the score is the quantitative variable. This is the quantitative variable. This is the categorical variable. Categorical means object, string, date, something like that. Right. Now, cross tabulation means what? First, let's have a cross tabulation of the category and the subcategory. Let's create the pandas data frame. PD or df is equals to pd dot data frame. This thing I will create it in a separate cell. this thing. Okay, now cross tabulation, we can do the cross tabulation and the statistics for one or more quantitative variables grouped with one variable. We'll see that. So just do the cross tabulation. What is the cross tabulation? What do you mean by cross tabulation? Used for the categorical data. Only used for what? Categorical data. Can you see category and the subcategory are the are these two are what you can say categorical data, not the quantitative. It is a string object, right? So first we need to convert it. So in the machine learning, whenever we are going to use this data for the machine learning, first we need to convert this data to whatever numbers or the quantitative data. So these objects need to be converted to the quantitative data like this. So there are techniques, we'll see that. So cross tabulation technique, what it does, used for the categorical data to show how frequency distribution of the combination of the categories, frequency distribution of the combinations displays the relationship between the two variables as the two-dimensional matrix of count. Okay, let's try it. So here we can say this is your crosstab. Can you see subcategory? See how it has created. So this data frame is different. So here we can say df.info. It would be having 3 columns, category, subcategory, scores. These are the 3 columns. And here we can say df.head, first 5 rows. You can see these 5 rows. Now cross tab is one of the function in a pandas of this column and this column. Can you see? Category, sub. So here is the subcategory XY and then ABCD. ABCD. So if you see A is available, if you see in the category and the subcategory. A is there for X, A is there for Y also. And that's why it has created 1, 1, 1, 1. Can you see? In the category, this is the category, this is the subcategory. For the A, there is a X subcategory. For the A, there is a Y subcategory. And that's why here cross tab means what? Of the category and the subcategory. So category becomes this thing, subcategory becomes the columns, and the category becomes the rows, and here you will get the count. AX1, AY1, BX1, BY2. 2 times is there. If you see AX, X is the subcategory of A, Y is the subcategory of A. So 1, 1. Now see here BX, BY, BY. Can you see Y is a 2 times and B is a 3 times over here. And that's why if you see total count is 3. So BX1, BY2. Relationships. What is multivariate? What does the cross tabulation gives you? The relationship between category and the subcategory. And similarly, it has done for A, B, C, D. How many categories are there? 4 categories, A, B, C, D. They are distributed, right? Subcategories X and Y, they are distributed. So in the cross tabulation, what we do, for the categorical data, an extension of the tabulation called as cross tabulation, it is extremely useful for the two variables. Cross tabulation is preferred by making two-way table with column headings that match the amount of one variable and the row headings that match the amount of opposite two variables, and then filling it the counts, and then filling it what? counts over here. Now this is what the cross tabulation is. Here you will get exactly what's happening, the relationship. Now second, what? The statistics. Again, when you talk about the statistics of the quantitative variable, mean, median, like that. So statistics for one quantitative variable grouped by the categorical variable. So statistics for one, so remember that. So statistics for this thing with the help of categorical, statistics for this quantitative with the help of one of the categorical, right? Statistics for one quantitative variable grouped one categorical variable means what? Here you can say mean underscore stats is equals to df. So this is the, again, univariate with one categorical. See, df group by category scores mean. So let's run this and you will get the output. Okay, just comment this out. Mode we don't require right now. We can do that as well. Mean stats, median stats. See here. Yeah. For the A, 57 is the mean. For the B, 70. For the C, 87. And D, 100. So presently mean and median are becoming same. Means what? Mean and the median are on the same line, which means that this is the normally distributed data. If you see, the values for mean and median are coming as the same, which means that this data is normally distributed. There is no outlier. So we got to the conclusion by looking at the values. So this is the mean we have calculated and the median we have calculated. Mean is the average, median is the mid value. So they are overlapping. Mean and median are the overlapping, which means data is normally distributed. Right. Hello? That's why first we learn what is the pandas. That's why we learn what is the Seaborn and NumPy. Sorry, Seaborn and Matplotlib. We are going to plot the things. So here we have created, so you'll get to know what do you mean by box plot and other things. So box plot and other thing comes under the multivariate graphical. Univariate graphical we have done. Multivariate non-graphical, these things you will do. But generally you don't require, we generally do the graphical things. We focus on the graphical. Even if you want to print the median, we plot the median. Right? But when you talk about the EDA, it is the statistical research approach. This is not coming from the Python, or it is not coming from the machine learning. This is coming, so base of the EDA is in the stats. Hello? So this is not, if you think that this is a little bit different to us, it is different because this is not coming from programming world. This is coming from the statistics. And whenever there is the data, maximum things you will come or confront from the statistics. Now, what you need to know. So you'll ask me, who will tell you calculate mean, median, mode values, right? Being a machine learning engineer, you don't need to do these things. Okay. Again, I'm telling you, if you are working in a startup which works, or you are working with the university which works on the coronavirus, there would be domain experts. There would be domain experts. They will ask you the question, give me the box plot of this quantitative data. So what you need to do as a machine learning engineer, you need to know the terms. What is quantitative data? What is categorical data? What is mean? How to calculate the median? How to calculate the mode? By looking at this data, being a data scientist, you need to know these things if you want to go in a data science thing. But data science is not only programming Pythonish thing, it is with the domain expert. If you want to predict the tomorrow's stock, you have given this, you have given the stock exchange data. You cannot predict the tomorrow's stock until you are having some stock exchange expert with you. You are a tool for them, right? There are some terms in the stock exchange that you are unaware of, right? Now, and that's why stock exchange also have launched one data science course. You might have seen that hospitals, AIMS, the stock exchange companies, right? The pharma companies are launching their AI courses. They need the people who know the technology, who know the domain, right? You might have seen that the universities, which, or you can say, the universities which are working on the penguins, right? They are launching the AI courses. They will teach you the domain, right? And you should go with these things, pandas, numpy, and you should know the basic EDA, exploratory data analysis. If they say that just do the cross tabulation, you need to know what is the cross tabulation and what it gives. So they will figure it out. But if you are interested in the medical field and you want to become a data science, then you are, and you will see these job roles upcoming in the future. One more thing I will add to this, EDA would be outdated. I'm saying, I'm giving you in writing. See that? You will not do EDA. You will not do EDA. The data scientist, you means data scientist, will not do EDA. Why? The tools like ChatGPT and other thing are pro in this. ChatGPT, Gemini are far better than us in this EDA. This job will definitely disappear. So data scientist, data analyst more precisely, data analyst, one a little role in the data science. This is the one of the role that would be replaced by AI. 100%. This role would be getting replaced by AI. So whatever we are doing right now, open the chat GPT and ask these things with the diagrams, it will do it precisely. Any question, guys? Hello? Am I audible?
Yes.
So data analysis role will disappear for sure. This is the grouped statistics. Fine. So let's have a 5-10 minutes of break and we'll be back again. Okay. And then we will do the whatever thing we are going to do mostly multivariate. If data is univariate, we will do graphical. Remember that. So these two things we will do mostly. So we can print the median also. We can print the mean also. We can print the distribution also. But we will do in a graphical way. But these are the four theoretical things we have. I have tried to cover it in a code in this way. Fine. Let's have a break of 5-10 minutes. Okay, everyone back? If you have any questions, go ahead and ask me. Hello?
Aniruddha, you said in future, like ChatGPT will do all the things.
No, please
Like
say
we
that
talk,
again.
yeah.
Say that again.
You said like ChatGPT will and Gemini will do the
Correct.
work of
It
data.
is doing.
So means why means how it will help us other than that and data.
So, first thing is that ChatGPT and Gemini are the biased things. Biased means what? They are trained on the, just a minute. They are trained on the massive internet data. Okay. So you might see some. Okay, I didn't stop the recording. Sorry.